So, let's dive into a monumental story of science, of national ambition, and a breakthrough that was literally decades in the making. At its heart, a fire. A fire that makes its own fuel.
Okay, let's start with the wild idea. What if a fire could make its own fuel? I mean, a fire that creates more fuel than it burns. Sounds impossible, right? Like something out of a sci-fi movie? Well, that exact paradox, it just became a reality in a small town in India. And believe me, this could change everything we know about energy.
So why is this such a huge deal? To really get it, you have to understand the problem this new fire is trying to solve. And it is a massive one, a challenge that affects the daily lives of 1.4 billion people.
Just look at this. India has to import a staggering 85% of its oil. 85%. Think about that. That means just about every drop of gas in a car, pretty much all the cooking gas for homes, it has to be shipped in from somewhere else. And a lot of it comes through really volatile places like the Strait of Hormuz. So you know what happens? Whenever there's trouble in the world, the price of everything, from groceries to electricity, just skyrockets for ordinary people in India.
But then, just this week, down in the coastal town of Kalpakam, something fundamentally changed. India fired up its prototype fast breeder reactor, the PFBR. Now, this is not just any old reactor. This is the machine that makes its own fuel. So how on earth is that even possible? Let's get into it.
Okay, to understand how this incredible machine works, we need a quick dive into the basic science. You know, the stuff that powers every single nuclear reactor on Earth.
It all boils down to one word: fission. It's pretty simple, really. It all starts when a tiny little particle, a neutron, smacks into an atom. That atom splits and bam, a huge burst of energy is released. But here's the crucial part. When it splits, it also shoots out more neutrons. And those new neutrons, they go on to hit other atoms, setting off this incredible self-sustaining chain reaction.
Now, the real trick is controlling all that power, and that's where this word criticality comes in. I know it sounds a little intense, but in the world of nuclear energy, it's exactly what you want. It's that perfect moment when the chain reaction becomes perfectly balanced, stable, and safe. You know, it's kind of like a spinning top. At first, it wobbles all over the place, but then it finds that sweet spot, its perfect axis, and just spins smoothly on its own. That perfect balance, that's criticality. And India's new reactor, it just found its axis.
Okay, so what's the big deal? What makes this one reactor so different from all the others out there? Why is everyone calling this a game changer?
Well, this really breaks it down. Think about a regular nuclear reactor. It's kind of like a coal furnace, right? You put the fuel in, you burn it up, it's gone. You need more. But a fast breeder reactor? Whoa, it's playing a totally different game. It doesn't just use its fuel, it actively creates new fuel while it runs.
So here's how the magic happens. Deep inside the reactor's core, it's shooting out these things called fast neutrons. Now, these neutrons fly out and slam into a blanket of a very common type of uranium, uranium-238, that's wrapped around the core. And this collision, it literally transforms that boring old uranium into brand new, super useful plutonium fuel. And get this, it makes more fuel than the reactor even started with. That's why they call it a breather. It's even been compared to the Akshaya Patra, a legendary vessel from Indian mythology that could produce an endless supply of food.
And this whole thing, this incredible piece of engineering, it isn't just some clever science experiment. No. As Prime Minister Modi points out right here, it's a massive, decisive step in a much, much bigger plan. A vision that's been in the works for 70 years.
Yeah, this didn't just happen overnight. This incredible achievement is actually the second stage of a three-part master plan. It's like a grand relay race that was mapped out decades ago by the father of India's entire nuclear program.
So let's rewind to the 1950s. A brilliant physicist, Homi Bhabha, looked at India's resources. He saw a big problem: not much uranium. But he also saw a huge opportunity: massive reserves of another element called thorium. So he came up with this genius three-stage plan. For decades, we've been in stage one, using the little uranium India has to produce plutonium. And now, we've just officially kicked off stage two, using that plutonium in this new fast breeder reactor, not only to make more fuel, but to start converting all that thorium into fuel for the future, which is stage three, the ultimate goal.
Now you might be asking, why go through all this trouble? Well, there's a fundamental challenge with thorium. Scientists have these terms fertile and fissile. Let me break it down. Fissile stuff, like uranium, is like a dry log. You can light it on fire right away. But fertile stuff, like thorium, is more like a green sapling. It has all the potential to become firewood, but you can't just light it. You have to process it first. Thorium has to be converted into a special kind of uranium before it's usable as fuel. And that is precisely what this new reactor is for. The fast breeder reactor. It's the missing link. It's the crucial bridge that connects stage 1 to the final goal of stage 3. It's the piece of the puzzle that makes the whole thorium dream a reality.
Okay, let's zoom out a bit. Why does this matter on a global scale? What does this breakthrough really mean for India and for the rest of the world?
By getting this reactor up and running, India has just joined an incredibly exclusive club. I mean, look at this. Only Russia has a commercial-scale fast breeder reactor in operation. China? They're still testing theirs. And other big players like the US and France? They actually gave up on their programs years ago because they were just too expensive and too complicated. That really puts into perspective how massive India's achievement is.
And this right here, this is the end game. This is the whole reason for that 70-year-old plan. India is sitting on about 25% of the entire planet's known thorium reserves. Let that sink in. A quarter of the world's supply. It's this almost unimaginably huge treasure chest of energy, just waiting to be unlocked, right there under its own soil.
So this fast breeder reactor, it's not just a power plant. It's the key that unlocks that massive national resource. It's what can lead to genuine energy independence, giving the country energy security for literally centuries and creating the foundation for a clean energy future.
Now, we've got to be real here. We're not talking about a thorium-powered India tomorrow. The road from this one prototype to a whole grid of these things is still a long one. We're talking decades. This is a truly multi-generational mission. But, and this is a huge but, this is the moment the blueprint became real. The theory is now fact. The prototype worked, and that means the production line can finally begin.
You know, Homi Bhabha laid out this incredible roadmap back in the 1950s. He never got to see this day. It took generations of scientists and engineers pushing through countless setbacks and delays to get to this point. The fire that he imagined all those years ago has finally been lit, and this moment, right now, officially marks the beginning of India's thorium century.